Hi, it's your linear algebra professor, Seth McIlvaney here. I've got this problem here that I want to walk through with y'all. We're given this matrix. It's a 4 by 5 matrix, and we want to determine a basis for the row space, the column space, and the null space of this matrix. So the first thing we want to do is we want to put A into row echelon form. All right, so we can do our nice row operations, try to get our leading ones in each of these columns. Okay, again, we can take -2 row 1, add it to row 2 to make a new row 2, and then swap rows 2 and 3. And then we can take row 2, add it to row 3 to make a new row 3. Take the opposite of row 2, add to row 4 to make a new row 4, and then add row 3 and row 4 together to make a new row 4. So we notice that we've got now 3 rows that are non-zero, and so those 3 rows are our basis for the row space, because we use row operations, which are essentially linear combinations of the rows, to make these 3 rows, these 3 vectors. So that's a basis for the row space. Now the column space, we look at the ones where we have the leading ones, those vectors, those columns. Well, those columns are in the first, second, and fourth columns is where we have the leading ones. If we look back to the original matrix, we can take the first, second, and fourth columns. That's precisely what forms the basis here. Note that they each have 3 vectors, so the rank of our matrix is 3. And then to get the null space, okay, we get a basis for the null space. Well, we do that by solving AX equals 0. So we will put A into row echelon form. Let me shut on my shoes there. And we will solve that system. And then once we get it solved, okay, note we're going to have 2 columns that do not have a leading one. And so those will be the 2 columns, the 2 variables for which we will use a parameter. So x3 and x5 will be s and t. And then we can determine the values of the other variables based on those. And so as an end result, we will have that x1 is -3s plus 1t, x2 is 2s plus 3t, x3 being s, so we can think of that as 1s plus 0t, x4 is basically just -2t, so that's 0s minus 2t, and x5, remember that was just t, so we can say that's 0s plus 1t. And the reason why we're throwing in those extra zeros and ones, because we can now factor out the s and the t and get 2 vectors. And those vectors are precisely the basis for the null space of A. Notice just 2 vectors, so the nullity of A is 2. Again, note that the rank of A was 3, the nullity of A was 2, and the number of columns of A was 5, 3 plus 2. That's not a coincidence. It always works that way. So I hope you like this video, and I'm going to be trying to make more. See you next time.